Be seated and we will get down to business. Now, I have so much experience and energy and intelligence on this panel. I'm very, very excited about it. But Simon Evans, if I might start with you. We look at what's going on around the world, and when we look at the grid, I love this expression that's coming out that there will be no transition without transmission. It's a big slogan, and this is probably the most important thing. It's great that we have everything in place, but if we cannot distribute, if we can't get it out there, we're in big trouble. And not just in India. Give us a feel for where the grid sits at the moment, be it smart or maybe learning to be smart. But give us a little bit of a situationer.
Absolutely. So, I mean, fundamentally, the energy system is complex, very complex, and it's going to get ever more complex. There we go. Is that better? Oh, I can hear myself now. Fantastic. It's going to get ever more complex with the introduction of new energy vectors. The system is under strain already. And we're seeing this through many things. Obviously, jurisdictions around the world are declaring climate targets or net zero targets. That's driving a huge transition. We're also seeing the electrification of pretty much everything, particularly, let's say, in cold weather climates where space heating is now moving to electrification, or transportation, such as electric vehicles. Now, all of these are introducing even more challenges to the grid. Now, you couple with that, of course, the change in consumer behaviors, an expectation of people wanting to get more services, the need for delivering greater flexibility at scale, and of course, we're seeing vulnerabilities in the system already showing, such as in the Iberian Peninsula just a couple of months ago. Now, the really interesting thing about all of this is there is a significant dependency on all of these challenges and how the system is being digitalized and unlocked. And if we can't categorically unlock that, we're going to find there's a massive struggle to realize and overcome these challenges.
So again, we look at the problems in this region, and there are many, but we could look at problems right around the world. And just as Simon is saying there, when this is happening in Europe and it's happening in, other countries that should be doing better, we're in trouble on the grid. Atul, if I might ask you about it, the grid structure, without a doubt, it's under stress. And India's grid particularly, that was really designed around large centralized thermal generation. Now it's pulling in renewables. There's a lot happening in terms of the supply of energy, but we have to get it through the grid before it goes. Atul, talk to us about that legacy grid architecture. Is it breaking down, and what do we need to be doing? What has happened? Bring us up to date in terms of how have we got to this point?
Yes, absolutely. The legacy grid that has been built in India is failing because of mainly two or three parameters. One is the power flow reversal, I would say. The India's grid infrastructure has been conventionally designed for big central distribution by the thermal power plants and consumer all over the places. But now the paradigm has shifted. We have a lot of renewables, decentralized power that has been coming onto the grid, and that is causing some sort of congestion or the flow reversal, I would say. Those earlier going into the one direction are now going into the two direction. The second problem is the system inertia. What we know for the thermal power plants, there is a rotational inertia that the power turbines we are spinning, the flywheels, it carries a great amount of kinetic energy to store into that. So if there is a fluctuation into the grid or if there is a frequency drop, they will immediately drop and release this kinetic energy, so the grid is stable. But now we have all this renewable solar, wind that is coming from the inverter-based technologies. So that is not giving you that kind of system inertia. So grid is not remaining this stable as of now. And third, of course, we can say is the overall operational stability, the control, the overall high resolution monitoring of the entire grid that is also causing a stress into the present grid. So if I would say the current scenario to quickly sum up, the grid is not stressed because it is insufficient generation capacity. It is stressed because of the paradigm shift and the fundamental shift into the way the power has been generated. And now the smart grid is the one of the solutions to look forward to the solutions for this congestion and grid kind of the problem.
And we'll have a look at some of those solutions, because there are solutions out there. This is the wonderful, the optimistic side of all of this, that we can sort this, and we are. Akilur, we look at the renewables that are scaling up here, and that's a great story for India. But indeed, they're scaling faster than transmission. This is the problem. How do we plan ahead and prevent, I suppose, the mismatch? Because we can't have the grid lagging behind generation. That has to be fixed.
Yeah, so it's about renewable energy sources. They are set up in remote areas, including offshore,
Yes.
offshore wind in North Sea in Europe, and then of course in India, in the deserts of Rajasthan, wet desert of Kutch, Himalayas, and also Northeast where we have a lot of hydroelectric power. I think, and they need long distance transmission and different type of technologies, but the challenge is that how you get the right of way and also get all these connection rightly integrated into the grid. So that's where we do the simulation, digital simulation of the energy, the smart grid is getting smarter that way, and then you introduce the technology, whether we go for HVDC technology or HVAC technology. That's the solution. We'll come to that later, but here we also use the digital technology to also ensure that the vegetation along the transmission line with vegetation management, satellite based monitoring, tracking of all these, and planning with the digital simulation, which is very important.
I mean, I think that's the key word, is planning. I think there's so much going on, and it's difficult to stay ahead, and it's difficult to plan. Akhilesh, we look at energy efficiency. This is your specialty now. This is your big focus. And when we think about it, there's a lot of waste in the system. I mean, there always has been a lot of waste. Do you think India should be treating, efficiency almost as a core energy resource, rather than a nice to have? What do you think? How would it help?
India is already doing it. India should not be doing. We replaced all the energy inefficient light with the LED lights. Long back, all the street lights have been replaced with the LED bulbs, and with this we have carbon emission has come down. So we had a Bureau of Energy Efficiency, which is doing the job of externalization, labeling of the products. Even a illiterate person nowadays don't buy a product which is not 3-star, 2-star. So awareness has come. So I don't think that for India it is a waste. It is now in the mind of everyone that we have to buy something which will not impact our energy bill. So that is how we are doing.
Well, no, I mean, that's good, and I think it's a situation around the world. But if you've got it manageable in India, you're ahead of everywhere in the world, because there's a lot of waste in the system, I can tell you, in every country. Pramod, I want to bring you in here. When we look at the energy sector right now, it's a very exciting time, a very dynamic time, but we have so much to do on every level, on supply, on demand management. I mean, all of that. Where would you say your biggest concern? And we'll talk a little bit more about what India Energy Stack is doing, but, give us a little bit of an overview in terms of what do we have to look at, Pramod?
Wonderful to be here, and I might be the only person who is not an energy expert on this panel, because I come from an alternate world of the digital backbone, building digital backbone for India. But when we looked at in the last few years, 2 or 3 years, as we were studying the energy sector transformation, it was fascinating as an engineer. It's just fascinating to see, ever since the Edison Tesla time, 100 years plus,
Yes.
everything seemed to have changed. Entirely, everything is flipping around. Multi-directional flows, not unidirectional. It's not centralized anymore. Everything is decentralized. Storage, never been there. And we saw what storage did to cloudification. We shamelessly store everything today in the cloud because storage became cheap. So the implications of those, and then of course the explosion of DERs or the energy resources. Now combine, the beauty of this is combine this with the alternate, complete the world transformation about programmability. So you're combining programmability, programmability is intersecting with this transformation. It's just fascinating that what's going to happen. Now, I think it also presents opportunities and challenges. And
Yes.
your question about concern is that people find it extremely hard to imagine a future that they have not seen. And they
You're
have
so
never
right,
been there.
yes.
So we are always modeling our solutions based on the past.
Yes.
And the past, we are not going to see the past anymore. So it's going to be a little bit concerning in how people would adapt and potentially reimagine the possibilities of what energy sector can do. But at the same time, India has shown, and at least India is a young country, generally very amenable to digitalization, and we surprised the whole world in the 10 years when we gave a billion people identity, a billion people bank account, and became the largest payment system in the world, all in the 10 years, right? So we have surprised ourselves many times, and I'm hoping that we will surprise ourselves again and not stay back or hold back on the digitization, which is an inevitability in addition to the physical backbone. I think
Exactly. I mean, I
it's
think
bound to come.
India has been a tremendous success story in that regard. And again, I think the political will is there. You know, the commercial will is there, the private sector, the government, you know, everybody. And we're in a hurry in India, and everybody wants to make sure that, you know, we deliver. James, you know, with the Asian Development Bank, but let's have a look in terms of, you know, all of these technology advancements. You know, I mean, and this is globally, this is not getting down on India or anything, but, you know, I sometimes think we have a 20th century distribution grid. We're almost, I think, the poor relation of the power sector. I mean, why is the world so far behind, you know, on the grid development? Because we've a lot to do, and I think we've got the answers. But what took us so long to get here?
Thanks, Edra, and privileged to be here. And let me also agree with the premise that distribution has long been the poor cousin in the power sector. You know, that's not by accident; it's actually by design. You know, that's what my opinion is. You know, over the last 1.5 decades, we were able to add capacities, renewable energy, and as well as to a level transmission capacity as well. But distribution has to left to manage with political mandates. You know, it has to manage social obligations, and now they have to manage high renewable energy penetration, and which the system is never designed for. So that's the issue we have. And as we move towards the 500 gigawatt target, which we are going to achieve by 2030, we have, over the period from 1947 to now, we have only achieved 250. So we are about to add 100% more in the next 5 years. So the challenge is not about capacity. The challenge ultimately comes in the integration, you know, basically. So the national electricity policy, which is in the draft now, which is very clear, you know, which clearly mandates volume to value, and as well as the capacity to capability. So that's all already mentioned clearly. But distribution modernization, for me, you know, fundamentally comes with the total visibility and the controllability of the grid. And we need people like Pramod in the power sector. You know, that's more important now. And without insight and control in the distribution grid from the consumer, I think even the upstream investments like generation, transmission, and even probably the storage will be partially blind. You know, so that's my, you know, observation. So if we are serious about, you know, reliability, flexibility, and even renewable energy integration, I think we should look at distribution as not as an afterthought, but it is a nervous system of the power system.
Yeah, and I think the rethink has been done on that. I mean, I do think people are really looking at this. Akilur, you know, with the coexistence already of electrons and molecules, that's already presenting challenges. But we also look at the future and the development of, you know, green hydrogen, and that's scaling to gigawatt levels here. How on earth are we going to put that into the mix and actually make it work and plan for that?
So conventionally, we have been simulating the grid and also planning the grid based on the electrons, basically the electricity. But what's happening is with renewable energy, we are having now the green hydrogen, green ammonia, not that they are green in color, but they come from the renewable sources. And if you look at molecule, the speed of molecule is you know, slower than the electron. Electrons, electricity, they travel at the speed of light. So when we simulate the grid, we need to integrate together all these different time response, you know, travel of the electrons and molecules, especially when you use the renewable energy, electricity, to produce green hydrogen and then store it as an energy storage and then give it back to the grid whenever it is required. And also the hydrogen, green ammonia, they can be also used in process industries, and especially steels and steel plants and oil and gas refinery. So that's why the entire ecosystem, they have to be designed in a way that you get the renewable power for the green hydrogen, green ammonia, Whether you do it co-located in the source of energy, or you do that green hydrogen production using electrolyzer in the plant itself, in the industry, in the refinery, in the petrochemical steel mill. That's a question of how we can integrate these two simulation, digital simulation using advanced mathematics. Of course, we do that. And that's the key for doing it. We call it sector coupling techno-economic analysis. That is how we achieve the optimization of the energy and coupling of these two electron and molecules in the form of electricity as well as the green hydrogen, green ammonia.
So, I mean, when we have the right engineers in place that know how to do this, this is going to help us. But Atul, I did a panel not too long ago at another conference, and as much as we all need this done, there's still a lot of societal opposition in terms of even building a new grid, and someone has to build it. Talk to me a little bit about, I suppose, regulations, the right-of-way constraints. I mean, how easy is it to actually expand the grid, Atul?
See, actually, we have to look for many statutory hurdles or regulatory hurdles which are very specific in India. Say, right of way is one of the area where the projects are delayed or we are not able to expand the transmission system with the same pace as our renewables are expanding. But the technology has some kind of solutions to look for that. If we say, I would call it as a low-hanging fruit. We had been part of one of the projects which we did at scale is a dynamic line rating. The existing transmission lines have been rated based on the most conservative conditions, the highest ambient temperature or the lowest wind speed. So the cooling doesn't happen that fast. So the current carrying capacity of the existing transmission line has been very constrained by the codes and standards and the way they have been designed. But now with the advent of technology, if you can put some sensors and get the real-time and dynamic data based on the wind speed or the temperatures or the forecasting patterns or the weather patterns based on the AI things, the existing transmission lines and existing network can be exploited to push 25%, 30% more, and you can start utilizing that grid capacity for the evacuating more power. Second is, of course, the technology is with respect to digital substations. We need more monitoring, we need more power frequency data, and we need to know actually what's happening at the interconnection and the nodal points across the grid. So we have the full control to to rectify the faults, to isolate the faults well within the time. And the overall architecture of the control systems is the third technology where we are not doing the complete monitoring. Monitoring happens at the generation point at the most at few substations, but we need some smart meters. We need some from the end-to-end monitoring of the entire grid to have the better operational visibility of what's happening into the grid. So that will stabilize the grid system. And those two, three technologies together may help us to solve the problems of hurdles required for statutory or some other ways of expanding the current existing network.
Indeed, and there are many ways. Akhilesh, we look at, I suppose, let's look at the economics of power distribution. When we look at smart grids and meters, are there any examples where, particularly efficiency has delivered real savings for companies when it comes to the stability of that?
With the adoption of smart meters, just there was a news article that the discoms have come in the profit of 2,704 crore in last year. There was a loss of 25,000 crore. So this smart meter has really turned around the discoms. They are more profitable. They have more data with them. They can very easily do this demand side management. There is no human intervention in taking the readings. So because of that, the collection efficiency has improved. So I think the smart meters have greatly improved the financial health of the discoms. And we have, so far, I think we have 5 crore smart meter already installed against the target of 25 crore. So the more smart meters come, the more we do their data, we do for analysis. I think it will be much more beneficial.
And again, there are many solutions, many challenges. James, if when we look at utilities, we look at governments and planning and regulation, what's holding it back? Is it the financing, the institutional mindset, the political economy? I mean, where are the big hurdles, James? What do you see right now?
Yeah, thanks again. In my opinion, actually, the constraint is not with technology that everybody knows. It's also not with financing. It's available some way or the other. But it's the misalignment in the key elements within the subsectors of the power sector itself. Basically, look at tariffs, incentives, skills, digital systems, and whatever accountability framework. These are not often I would say poorly aligned. Financing actually flows naturally when there is an outcome. Basically that happens. But many utilities are not structured to digitalization. As Akhilesh sir just now mentioned that we have 50 million smart meters installed, but we don't have an IT cadre in most of these utilities to manage them and access this data. Basically that's something unbelievable to understand. And even we have misalignment occurs at the distribution. Even the generation is adequate to manage, but the distribution, utilities don't have the financial strength to go for digitalization. And also they don't have the skills to do digitalization or analyze this data. So that's something, we really need to see. And what we see globally now, is that, basically what policies which made progress is have they deliberately aligned these elements actually, such as tariffs with service quality, basically, and digital investments with accountability, and regulations into real operations. It's not regulations anymore, it should be operationalized. So India's policy framework is moving in the right direction, but it's important that the real test is with execution, how we are going to execute this with this concurrent subject of power sector, across the states and across different utilities.
Pramod, when we look at, India heading in the right direction, we have to look at this grand digital public infrastructure plan. This is in place, and I think everybody would agree that this, is a great initiative here. How will this help, I suppose, the digital backbone of the energy sector?
Yeah, I think two parts to it. First of all, personally, I feel there is the smart city, smart grid, nothing is about they're actually smart. Frankly, I think it's just, smarter procurement, I think. But what digital public infrastructure really taught us is that it is not about procuring some out-of-the-box solution. It's about reimagining the backbone itself. And when India reimagined the backbone, we saw the formalization of 1 billion people. So what India ended up doing is few things, that learning that came from. One is, of course, every consumer has an identity, every consumer has a bank account, every consumer is addressable, uniquely addressable today, quite like a meter. I mean, everybody is addressable. And you can actually flow money. So India built the largest direct benefits transfer. So if in India, energy sector is subsidized heavily, so we can reimagine the subsidy transfer as a direct benefits transfer program today. India is the only country that can actually reimagine Indian subsidy program. So that's something we can use. UPI actually showed us that, micro is the new mega. Literally, in 6 years, we overtook Amex plus Visa plus MasterCard plus everybody combined. And this is because young Indians take on digitization really well. And we moved from high value, low volume environment to low value, high volume environment. This is bound to happen in energy sector. There's no way you're going to stop this. So energy sector, this is coming. The question is that, do you procure solutions to manage it? Or do you reimagine the backbone itself? I think India has taught us that if you look at our agriculture, healthcare, it has taught us that we can reimagine the backbone. And Indians are very, 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 in one sense, ready and believers of this backbone. And I think that's exactly what we did. And the second part of digital public infrastructure very quickly was that it also drove one of the biggest private sector innovation on top of public rails. So Satya Nadella very publicly said that India has a public rails on private innovation tango playing out beautifully, going from 1,000 startups in 2016 to 100,000 startups right now, going to 1 million startups by 2030. So we are ready actually as a society to be able to reimagine the backbone and to drive private innovation as a way to reimagine the future of energy. I think it's exciting times.
So I think when we see that dynamism happening in the industry, it is very exciting. Simon, thinking about reimagining the backbone, so to speak. I mean, fine, we talk about smart grids. Often we're thinking of physical assets and we're looking at sensors and, what we can visualize. But talk to me, I suppose, from a systems perspective. How important is that digital backbone of the grid compared to, I suppose, the physical upgrading, which we probably have to do both, but stay with the backbone for me. Bring me into that digital backbone. Bring us in there.
Absolutely. And I think you make a really good point there that the physical backbone, if you will, the physical infrastructure that's existed today is always where the incentive has been. And if we look around the world in many jurisdictions, there is an incentive to build more assets. Mm-hmm. Now, we can't do that in the future because there is a lead time with that, there's a cost with that. But what we are always failing to remember is that the digital infrastructure that underpins it, that connects it, is becoming even more important than the physical infrastructure to deliver many of the services that my panelists here have been saying, to get that better outcome, to help foster the energy transition. And I think it's really interesting because we're seeing a mega shift in that across all jurisdictions around the world about people understanding why this is important. Now, to give you an example, in the UK just last year, our industrial strategy that was published by our government put forward the idea that there needs to be a data valuation framework, a way of valuing data for an organization on its balance sheet. Now, why that's really interesting, it's starting to signal that there is an understanding that digital data and the infrastructure that supports it is going to be an economic asset for the country. Now, to give you an example in numbers, in the UK, again, we have an organization who owns and manages our strategic road network, as they call it. These are the motorways and the highways that go across the country, the critical national infrastructure. Now, this strategic road network and the organization that looks after it is called National Highways, and all this information is in the public domain, so you can look it up. They went and did an exercise to understand what the digital and data assets they had were worth to them compared with their capital assets. Now, they did an assessment and realized that their physical capital assets were worth in the order of £156 billion on their balance sheet, which is a large amount given we're a small island. And through the various valuation frameworks and methodologies, they concluded that the data assets that they hold today, and that's today, are worth potentially a staggering £69 billion. So potentially 45% of their future value is around data. Now, we know global accounting standards are changing, they're starting to recognize this, and if you're an investor-owned or you're a shareholder-owned company, and there's a potential that 45% of your future value is linked to the data that you're managing and maintaining today, you've got some serious questions to answer about why you're not engaging in it now. So this isn't a if question, it's a when question that has serious economic consequences to entire economies, particularly if we consider it at a system scale as well.
Atul, I see you agreeing there, and also as I have two chief technology officers on our panel here, so this is in depth for them. How do we move, I suppose, from a reactive grid now to predictive real-time operations across, and taking from what Simon said there, the potential that's there and the wealth of that data?
Yeah, very good question. But currently, we are all in the reactive grid. For going into the predictive grid, I believe there are 2 or 3 pillars. The solution lies into that, and not one in isolation, but all 2 or 3 these pillars. The first one is very important: data acquisition and data sensing. So the first step in any kind of this predictive analytics is to gather the data for the entire grid. So be it smart metering to the intelligent sensors to all the AI-based predictive algorithms to we need and better high-speed communication channels as well. So once you acquire all this data, the second pillar lies, of course, is the data intelligence or running an intelligence engine on the data that you have gathered. So you can run the predictive analytics, you can do the trend analysis, you can predict what the future is, and you can of course take the help of AI to have the better predictability of what is going to happen once you have all the data in place. The third important pillar, I would say, is the control system. There is no use of collecting the data, there is no use of doing any analytics if you don't have the control mechanisms. So whatever are the predictions, whatever are the simulation results, we need some systems and tools where we can control it. So it can be safeguarded. We should have the proper automated trips. We can have automated flow
Mhm.
of the electricity or the transmission corridors. We have it's a rather than leaving it to stabilize and operator control it when there are disturbances, the system stabilizes in the automatic way,
Yes.
gathering all the
Yeah.
intelligence from data collected, from data simulated, from data predicted, and act on that. I believe that all these three pillars together are required, not one in isolation, not one in this. An integrated solution will definitely help for an faster deployment of the smart grids.
Akilur, when we look at digital systems, I mean, they've been around for decades, but we look towards the smart grid to, now and beyond. How do we convert those digital tools into operational value? Because it certainly sounds like it's there.
So digital technology is not new to the power system and power grid. It has been there since the inception of digital computers. 70s, 80s. I myself personally, I was working on digital
Right.
simulation of
Yeah.
power system in 80s, late 80s. And also power system has been also one of the drivers of the digital technologies, parallel processing, storage and communication. This has been the need because, as I said, electricity moves at the speed of light, electrons. You need to control them with the software, which is very fast. So that's why it has been there since 70s, 80s, the SCADA. With respect to control and protection, the digital backbone has been there. I mean, many of us, we don't realize, we see only the wires, but I think behind there is always computer, SCADA, control system, sensors. They have been there since 70s, 80s, doing this control and protection of the grid, which is large. For example, India, like a large grid. So, and that is basically, we need deterministic operation of the grid. Deterministic in the sense the algorithm highly, advanced mathematical algorithm, it has to run in 20 millisecond and give operation commands to a particular actuator controller. So that has to happen 100%, 99.99%. And also with respect to time, uh, millisecond, 10 millisecond, 15 millisecond, that's why it has
Wow.
been there. What is coming in the digital backbone on top of the core digital backbone of power system is also this asset and work performance and energy forecasting, which is more like predictive. But predictive also comes with probabilistic. So we cannot apply probabilistic principle to the core of power system because it has to run without any tripping of the circuit lines
Mhm.
and blackout. So we are using the digital backbone of the new age advanced work and performance management, asset performance and forecasting of the energy that is on top of. So and then the third aspect which Pramod also has been talking about, how we use this digital backbone, also the energy transaction. Energy transaction in the utility and aggregator level, but also P2P, peer-to-peer prosumer level. I think this is what the three layers of digital backbone for the protection and control, deterministic and predictive for the asset and work performance, energy forecasting, and third one is of course the consumer interaction, trading of energy. So this is what the backbone will look like, and this is moving forward. And in India, we have the great opportunity there because our system is very large, and all the technologies are there. Like I'm from Hitachi Energy, we have all the technologies
Yeah.
there, whether it is transmission, HVDC, long distance HVDC, flexible AC transmission, using the semiconductors, which are million times more powerful than the semiconductor of a TV. We are doing that. I think overlaying that with the digital backbone, three layers, I think that can really create a very strong system, which will also provide the value to the prosumers, to the last mile connectivity. Yeah.
And that's what has to happen. James, when we look at the digitalization of the distribution grid, how is that going to change the way that we manage risk? And I mean, at the moment, are we underestimating perhaps just how exposed we are?
So, distributed renewables are not just booming. It's already part of the system, actually, basically, and, growing feature of the power system, which is going to be the growing feature. And we also need to recognize that the people-centric energy transition will happen only through distributed renewables. though it be rooftop solar, though it be agriculture solarization, though it be schemes like clean cooking, it's the people-centric energy transition will happen only through decentralized renewable energy. But are we ready, fully recognizing the risk of decentralized renewables? So that's the question. So recent system disturbances, across the globe, either be the Iberian Peninsula or several blackouts that happened in Sri Lanka, or in the last couple of years, it clearly shows that it is not due to generation shortfall. No outages happens because of generation shortfall. Outages happens because they were not able to see it, they were not able to manage it, or they were not able to predict it with the data. So with millions of rooftop solar and the behind the meter system, and this is not a future risk, this is already a risk, whether we are ready to manage this. And even with the CEA data or the MOP data, we don't have the capacity addition of rooftop solar in India's capacity, total capacity addition, which is almost close to 27 gigawatt now. So that's the real challenge. We are taking it, and this means the asset expansion is not about expanding the transformers, expanding the distribution lines. It's managing what we have now using softer technologies. So that's what we need to do. And if distributed renewables are going to scale, and everybody will agree that it is going to scale up, but we really need to manage our grid a bit more faster to ensure that the decentralized renewables in a country like India plays a huge role to be people-centric. So, but at the same time, the distribution grid need to be ready to help them to integrate.
Pramod, we look at India Energy Stack. I mean, the big digital focus that has been put on this now. I mean, that initiative is there. You've got the green light. But we also have to look at the innovation, and open participation. But utilities still carry universal service obligations and financial risk as well. How do you work with the legacy distribution companies? Because they're part and parcel of this.
Yeah, first of all, the Ministry of Power, all the way from the Prime Minister's office, either the commitment, political will, and the commitment from the system is very, very high in recognizing these elements: rooftop solar expansion, decentralized resources, production expansion, DER expansion. But primarily from the grid perspective, I think it's coming down to how do you manage your own demand flexibility risks? How do you manage your surges? How do you manage your, excesses or, less, when the peak time comes, how do you give the obligation without actually having to buy in the spot market? Is there other ways to manage it? And very interestingly, what we are seeing is also the surge of this, battery systems and other mechanisms, allowing us to actually reimagine what could happen potentially if you were to not assume every asset is actually owned by you. So there is, an India Energy Stack is looking at a very holistic view of saying, if assets are leasable, quite like a cloud computing, you could actually lease batteries, you could real-time rent batteries. The ripple effect of that design is that you have a lot of programmable flexibility in terms of how you manage your grid, how do you manage your demand, how do you manage your consumer usages. And most importantly, we are also excited about the livelihood and other opportunities it will drive. The second order effect of solarization, battery storage. Literally, Prime Minister picked up on only that point, literally saying, that means a woman in the village actually can earn money. That's very different view to view the whole problem statement, right? So I think it is very exciting times for us to reimagine. And as I think our earlier discussion, it is not about replacing the underlying control systems and the existing transmission and control systems. They're not about replacing them. It's about layering further programmability on the higher level and creating the eventual last mile or the consumer. That's where the explosion, behind the meter, explosion is happening. How do you manage that? And how do you not end up with risk, as James was saying? I think it's a manageability of that. IES is now in the 0.4 version of it. And it's expected to complete the 1.0 version of it by June. But what we are seeing is enormous uptake. And literally, We had actually, we had Prince is here. Actually, we asked him to put it out for an application. We got like 100 discoms plus companies applying to be part of the
Right,
first
okay.
P2P trade. And India has not done P2P trade ever, actually, before inter-discom. But they were ready. I think because the time has come and the recognition has come for it. But as I say, always, the risk is legacy systems are harder to work with. It's not about rip and replace. It's not open heart surgery. It is very careful calibration of that digital overlay in terms of on top of the physical one. You know, it will take probably 4 or 5 years, but we'll get there.
Akhilesh, we listen to what everybody is talking about, and even when Atul was describing what's going to happen when the digital systems are in place, I can just feel efficiency moving at every touch point in this. But talk to me again. When it sounds so easy, and ultimately we're going to have financial savings, better operational results, improved reliability, flexibility. I mean, that's all there, the great potential. And in a way, it's always been there. So talk to me about energy efficiency within the smart grid, and maybe why haven't we done it? Why do we really need to move on this fast now?
Okay, so I will give this question answer since I am a transmission line construction management person before coming to here. So when you started your very first question, congestion in the transmission, but I can tell you I have made some very big transmission projects before coming to ESL, and average construction period in very big transmission line in India is around 28 months to 32 months for AC projects. So if I link that question with this question, so the thing is that now we cannot build indefinitely transmission lines. We can store the power in daytime. The congestion in the transmission system is only in the daytime. In the night time, we have to switch off the lines because of over voltage. So if we can build, which now government is doing, government is giving viability gap funding for best projects, and every state is coming with the best projects. So this energy efficiency which is now coming, and this rooftop solar which is now coming. So in Kerala, they are going to make that if somebody is putting rooftop solar above 5 kilowatt, they have to put their own base. So that is the kind of thinking we have to bring so that the grid is not constrained. And like same way, we are also doing electric mobility. We are doing in the e-bus and e-car also. So I can tell you what is happening. Somebody told me that the buses are being charged in peak hours. So in Kerala, what they are going to put, they are going to put very, very high tariff if someone is charging in daytime, and if it is being charged from 12 to 6, there will be very low charge. So I told them that you just put a switch. There is no need that the charger will only be on during this period for the buses. So this kind of automation we need to have energy efficiency. We need innovation in India. The large energy efficiency projects are not being taken up because there is no financing for energy efficiency projects. So we are doing study, we are doing energy auditing, and we are telling that if you implement this much of power will be saved, and the payback period will be 8 years, 10 years. So they are telling, no, you put the money and we will give from the energy saved. I also don't have that deep pocket to take the entire energy project in the entire country. So some financing company, like we have PFC, we have REC for the transmission or distribution, we need to have some financing company which will only finance ESCO projects, then only this will come.
Indeed, Atul, I see you were agreeing with that. But also, when we look at, all of the things we have to do here, India is adding renewable capacity at, world leading speed. It's just loading it on. But, what worries you, I suppose, the most in terms of the gaps that are there? Because we can go full speed on one, but, we can be pulled back on the other. What do we need to do to actually close those gaps?
Yes, there are several technological things and technological interventions that are possible to close the gaps. First, let's talk about the problem and the solution. The congestion is definitely increasing. This is because Now, you say there are pockets of renewable energy production in India, say Gujarat, Rajasthan, Tamil Nadu. They are producing more renewables, but the consumers are somewhere else. So the interstate corridors are weakened and they are not able to
Yeah.
take the load. So congestion is definitely happening. Now, if you talk about the second part, which is curtailment also. So the grids are not able to take the extra power when the renewables have been producing at the highest rate or at the peak rate. And those grids are not able to take up this power, so they need to curtail this power. But apart from this congestion and curtailment, the bigger problem is with respect to the operational visibility. I mean, we don't have the full operational visibility as to how we can predict the performance, how we can predict the capacity of the entire grid. So, as far as technological interventions are concerned, I think we need the real-time monitoring of the grid. No doubt about that. That's the first solution. Second is the grid needs to be flexible. We need to have the
Yes.
grid scale energy storage as well. The third technological intervention comes from an pure AI-based predictions. We must have good algorithms, good data points to predict what is going to happen on the grid scale, to offer that flexibility, to offer all those stability requirements related to that. And there are other parameters like the cyber security, etc., etc.
Yes, indeed. And that's something I think it's probably for another panel. We don't have time, but it's very important. Simon, in fact, maybe you can touch on it a little bit. Different countries are moving at different speeds. Maybe what can India learn from other countries, and maybe incorporate into that, Simon, if you would. I'm just watching my time here. The people, the governance, the institutional barriers that we really need to be looking at as well in terms of, we've a lot to gain, but we have to approach with caution. What do you think, Simon?
Absolutely. And talking to the institutional barriers part first, one thing we've observed when doing research and looking at various countries' digital transformations in the energy sector is that most organizations, most countries are considering it from a technical point of view. So what is the tech-first approach? What's the right hardware, the software, the solutions, the digital backbone? And as my panelists here have said, really that's not the challenge. You can get some smart people to develop some smart stuff, and that can be done. The real challenge is actually kind of the socio aspects, the social sides. So the people, the process, the procurement, the legal, the skills for the next generation. That's where the real challenge is. And that's why, very sensibly, countries that are more like advanced in their thinking and their journey on this are considering this as a socio-technical problem, not just a technical problem, and really leaning into the socio aspects. Now, within that umbrella, the one thing we've observed is that what most organizations and countries aren't looking at is governance. And this was confirmed at a roundtable, an international roundtable that was convened earlier last year. And all the organizations, all the kind of ministries from around the world were at this, presenting what they were doing on their own sector level. So this is sector, not kind of organization level, transformation journeys. And it was blaringly obvious that everyone was taking a tech-first approach. No one had thought about who is accountable for this, what's the right roles, responsibilities, what happens when stuff goes wrong. And particularly when it's touching consumers, how do you address that? And the final thing I'll add on this is that one thing we've observed as well is that in every digital system, we are lacking the equivalent of what we see in the physical system, which is the system planner, the person that works out how it all comes together. Who is the digital system architect that ensures that at a system level, these things are coherent, they're connected, and they work?
Pramod, can you give me perhaps a short comment on that in terms of governance, responsibility? Who owns the systems, Pramod? Who's responsible?
So India is a very federal structure, so it's not centralized at all. So that allows us to create a more of a federated governance structure with architecture, set of architecture and program accelerators that goes along with it. So there are templates and governance processes, policy templates, recommendations that can be co-created, but eventually it does get into the actual governance of those systems are actually decentralized. It's actually they're not centralized governance. So India Energy Stack is not trying to override that structural setup and say we will centralize into some one entity who can manage the whole country. It'll be actually, even the governance will be decentralized, fully decentralized.
Akilur, who's in charge here, do you think? The utility, the OEM, regulators, in terms of when we look at governance, cybersecurity, all of that?
All the stakeholders, they have a role to play here, because the OEMs, we like Hitachi Energy, we come up with the controller, actuator, devices, equipment which are robust, security tested also. And also the network, how they are connected, and network security that we come up with. But very important is in the operation of utility. This is something the utility owners, operators, they have to take care how they follow the procedure of cyber security, in terms of having policy, in terms of having the antivirus software, in terms of having the ports and services, hardening of the system, and also having the threat model of the network. That's the responsibility of the operators, the utilities. Do the threat modeling and ensure that your core, the deterministic system, is secured even if there is attack, cyber security attack. So there can be 3 layers. I talked about 3 digital backbone. All the backbones are now connected: deterministic, operation and protection and operation, predictive, asset work performance, energy forecasting. Third one is transactional. So they are all now interconnected. So how do you protect the core, which is the deterministic control of the grid, and have this threat modeling and also defense in depth kind of strategy, which is in cybersecurity, call it. And that is how you can deploy different security measures to protect the grid. That's very important, because grid, once any particular tripping happens, it is cascaded tripping. You can't have the manual intervention, human intervention,
Yes.
because it goes into cascaded failure of a grid.
James, when we look at that data, who owns that data? How is it managed? And again, is a lot of the digital projects here, is there in danger of, we have a lot of pilot projects going on here. How do we scale, and how can we move that quickly? And you've probably got about a minute to answer that, please.
So actually, you're right. There are a lot of pilots happening, and when you consider India, some of these pilots are probably actual projects in some of the other demographies. Actually, if in smaller countries, but what is happening is the pilot is just leave us technological demonstrations. It never go into utility, as a wide scale development projects. So we really need to move. The shift required is when pilot happens, if it really helps the utility in developing into a real scale project, it needs to be deployed at scale. Otherwise, the pilot will remain pilot. It will never go into planning. It will never go into regulatory interventions, and it will never come into a project, actually. So, deploying pilots in different locations will not help. My understanding, based on ADB's experience in several countries, after a pilot is done, it's almost need to go at a scale to ensure that the results are visible to the utility, results are visible to the regulator to take it forward. And basically, many of these regulations, many of these standards are already available. And I don't think we need to invent the wheel. We can use the standards, regulations already available in many countries, and use it beneficially for our use case. And even peer-to-peer sales and all these things are carried out in many countries. And if you see in Australia, I recently saw that they have a policy for 3 for free.
Yes.
3 hours, the electricity is free during the daytime, which means because they are not able to integrate these renewables, so they ask them to use. Either you curtail or allow the consumers to use, right? So
well, I think that's something that India would definitely welcome, if they give them 3 hours free. We have to wrap up here because we don't have any more free time. But listen, Akhilesh, I want to just start with you. When we look at, I suppose, the call to action, we hear of the great potential that's out there. We hear of the great projects that are in place, the possibilities, the probabilities. Everything is leading back to your specialty here. It's all about efficiency, and that's where we're looking at a much more efficient future. But if there's a big call to action, from you right now, what do you want it to be?
Actually, we want to be this. There are 3 A's for this. One is awareness. I feel awareness is there. Second is availability. Availability is there. Affordability is something where government needs to put some penalty on the energy inefficient equipment, motors, fans, and the 5-star, 4-star equipment should be incentivized. There should be some incentive that you buy only BLDC fans, and like charging infrastructure we are doing. So we have to scale up energy charging infrastructure so that people go for electric mobility. So these are the areas which I feel.
Exactly, and I think, it is step by step, but it is beginning to happen. Akilur, we look at, we have the technology, there's so much in place here, but if there's a call to action, we look at right now, what's urgent, what's necessary, what's possible.
For a smarter grid, I think the digital and energy, they are two sides of a coin. Digital needs energy and energy needs digital. And especially when we talk about AI, it needs huge energy. And what we have to do is for the smarter operation of the grid, we need to have this convergence of digital and energy. And all the stakeholders, we should collaborate together to move in this journey, including the transactional, what Pramod talked about, the P2P, peer-to-peer trading, which touches the prosumers.
Indeed, those partnerships are so important. Atul, we look at the great work that is going on, but where would you like to see it escalated?
Very quickly, call to action. We need an integrated solutions, no more pilots, just start implementing the full smart grid implementation.
We have the know-how, it's time
We
to
have
move
the
forward.
know-how, we have the technologies available.
Yes.
There are enough isolation experiments have been done. Go and implement smart grids.
I love that. Simon, again, this is not just an Indian problem, it's a global problem, isn't it, at the moment? What do we need to all do?
Yeah, and it's been well recognized that it isn't going to be impossible for us to achieve net zero without widespread digitalization of the energy system, categorically. So this is not a if question, it's a when question, and it's how can we all learn from each other, because this is a socio-technical problem. Every part of the planet is going on at the same time. Instead of competing, let's collaborate.
Pramod, clearly a very dynamic time in the country, in the sector. But again, if there was in the short term, what do we need to do?
I think the future of millions of consumers, millions of devices, interconnected, programmable, and demanding energy necessitates we really look at affordability, resilience, and continuous availability of it. And there requires a reimagination of the future. You cannot paste the past design into the future. So I encourage everyone to actively track, participate, and join the IES journey. IES, we don't do pilots, by the way, graveyard of pilots. We are only doing calibrated takeoff.
Right.
That means once you take off, plane is not landing. There's no pilot death by pilot. Okay.
Exactly. So
going,
don't look back.
So please join.
Just look ahead, because we're not going back there. So there's so much to look forward to. And James, this will take dedication, focus, planning, finance, of course. Again, what's the best thing we can do in the short term to really move us to this bright new energy future? Because I think that's what's there for every one of us. And once we have better, more efficient energy, the world shifts and changes.
So, in my opinion, energy sector is the only sector which can decarbonize other sectors. Basically that's the only possible sector. So, and without consumers, the power of consumers is the most important one we need to take it up. Actually, so what I believe is the last mile is going to be the front line in the future, and without which the transition may fail.
Well, and thank you all for speeding us on that last mile to finish on time. Thank you all, gentlemen, so much. To James, Pramod, Simon, Atul, Akilur, and Akhilesh, thank you all so much for that great conversation, for sharing your great expertise, your optimism, and hopefully there's lots to be done, and we have the right people in place and the right technology to do it, so there's a bright new energy future waiting for us all. Gentlemen, thank you so much. And thank you to our dear audience.